Hey guys, and welcome back to another video. Today's video we're going to be covering the answers to the cubic test. So if you've been given this link, or if you want to pretty much do this test, the link will be in the description pretty much. So I'm not sure how many marks it is. I actually didn't count it up at the end. Let's just do that very quickly. So it's 2, 6, then that's going to give you 10, then that's going to give you 16, then that's going to give you 15. It's 21 marks, so pretty much if you want to set this cubic test, yep, the PDF will be in the description below. This video is pretty much going over the answers for it, okay? Now, let's get straight into it pretty much by taking a look at the first question. So the first question is worth 2 marks. P of x is given x cubed minus 3x squared minus x plus 2, and you need to find what P of 2 and P of negative 3 is. So for question for A, when it says P of 2, so P of 2 means substituting x equals 2 wherever the x pretty much appears. So you can see this bit is pretty much replacing every single x in the cubic. Okay, so when we write this bit here, what we have to do is pretty much, alright, we'll start off, we know what P of x is. So P of x is x cubed minus 3x squared minus x plus 2. So therefore P of 2 will be 2 cubed minus 2 squared minus 2 plus 2. Okay, so we can evaluate this. So P of 2, we know this bit 2 cubed is going to be 8. This is going to be 4 times by minus 3, so that's going to give you negative 12. And this is going to be minus 2 plus 2. And we can see straight away that these ones cancel out the back here. So we're going to have 8 minus 12. So that's going to give us negative 4 as our solution. So P of 2 equals negative 4. Okay, this is because pretty much what we're saying here is when x is equal to 2, then y is equal to negative 4. So the coordinate is 2, negative 4. That's another way you can express it like this. Okay, right. So now let's take a look at a b, but when you substitute x equals 3 involved. So now we'll rub this out now. Takes a bit. So then we'll go P of 3, so substituting negative 3 wherever the x involved, so negative 3 cubed minus 3 on negative 3 squared minus negative 3 plus 2. So this first bit here, it's going to still be a negative number because of the cube. It's an odd power, so it's still going to retain its negative. So just think so 3 cubed, whatever that is, just chuck a negative in front. So 3 times 3 is 9, times by 3 again gives you 27, so this bit here is going to be negative 27. This bit here, this negative here is actually going to disappear, but it's going to reappear because you have the negative out the front of it. So negative 3 squared is 9, times by minus 3 gives you negative 27, so you get negative 27. Here you just get a positive 3 because a negative times a negative is positive, and then plus 2. So here we have negative 27 minus 27 plus 3 and then plus 2. Okay, so what we can do here is just add the 27s together. So this is going to be negative 54 at the front plus 5. So this is going to give you negative 49 for P of negative 3, and that's it. So if you do that, you'll get your 2 marks. So the reason why it's only worth 2 marks is because it's just a substitution pretty much. There's no pretty much thinking involved. Well, there's a little bit of thinking, but it's mainly just substituting the values in and understanding pretty much the notation of this. Okay, right, so let's just pretty much go into the next question. Oh, I won't need to rub that out, I've got enough room. Right, so question 2 worth 4 marks, mainly because there's a bit of complex bits involved, mainly to do with long division and what you're actually doing for the question. So P of x is x cubed plus x squared minus 3x minus 6. Determine if x equals 2 is a solution, as well determine the quadratic if the factor is divided into P of x. So what there's pretty much saying is this is going to be a solution, or probably will be a solution, but you've got to work it if it is. Now, if it is a solution, that means it's going to be a factor of P of x. So when they say this second bit here, when they say substitute, we'll determine the quadratic if the factor is divided into P of x. If you have a linear factor like x plus 5 and you divide that into the cubic, you're going to get an x squared, some polynomial, but the highest order will be an x squared. Okay, so first of all, to see if this is a solution, if you substitute, so if x equals 2 is a solution, then P of 2 should be 0. So what we can do is just work out P of 2. So P of 2, or P of x is x cubed plus x squared minus 3 times x minus 6. So p of 2 will be 2 cubed plus 2 squared minus 3 times by 2 minus 6. This first bit's going to be 8, then this is going to be 4, this is going to be minus 6, and this is going to be minus 6. This front bit is going to be positive 12, and this back bit will be minus 12. So you can see straight away you get 0. So that is verified, so that means you've answered the first bit. So all of this working here is probably worth 2 marks, okay? Now the second bit is worth a bit more because you have to work out what the quadratic thing is once you put the factor in, okay? So let's get rid of this. So if x equals 2 is a solution of p of x, then x minus 2 is a factor of p of x. So that means when you divide this into p of x, you should get a remainder of 0. So setting up the long division, it's x minus 2 divided by x cubed plus x squared minus 3x minus 6. Okay. Now we'll just do it step by step. So there will be this term divided by this term here. So it'll be x cubed divided by x, which gives you x squared. And then you chuck this guy on the top. Okay. Then you multiply this by this term here. So you get x squared times by x minus 2, which gives you x cubed minus 2x squared. Then you chuck that under here, but you've got to put negatives around it. It's very important not to forget the negatives. So you get negative. So it cancels out the first term here because x cubed minus x cubed is 0. Then you get x squared minus negative 2x squared. So this is pretty much going to be positive 3x squared because you have 1 minus negative 2. So that turns into a positive 2. And then you just bring the rest of this down, okay? Then you pretty much repeat the steps. So then it's pretty much going to be this guy divided by x again. So it'll be, I'll rub this out because I don't need that anymore. So it'll be 3x squared divided by x gives you 3x. So you chuck that up here, so plus 3x. Then we 3x times by x minus 2. So this gives you 3x squared minus 6x. Chuck that under here and put a negative in front of it. Righto, so now that we've done this, what we've got to do is just take it pretty much carefully, okay? So it's going to be 3x squared minus 3x squared gives you a remainder of 0. Okay, well, not a remainder. When you add up the positive and the negative versions, you get 0. This bit, you have negative 3x minus negative 6. So this negative here is going to affect this thing here. So in turn, what you have is negative 3x plus positive 6, because this negative times this negative is a positive. So what you're going to have is positive 3x, okay? Then move this negative 6 down, okay? Then it's just the same step again. So this divided by the x. So I'll just write that here on the side. So 3x divided by x gives you 3. So place that up there. And then 3 times by x minus 2. So 3 times by x minus 2 gives you 3x minus 6. And then chuck it here. Now you can see straight away, or hopefully you can see, that this is exactly the same as this. So if you have something minus the same thing, it's going to be 0. Okay. So you can see you've got a remainder of 0. Now this is the quadratic thing they're talking about. So when they say determine the quadratic if the factor is divided, the quadratic is x squared plus 3x plus 3. Okay. And that's it. And then you get your 4 marks there. Okay. Let's go down to the next question now. So question 3. 4 marks. So x plus 2 is a factor of p of x. And p of x is given as x cubed minus kx squared minus 2x minus 4. Find k. Okay, so there's a couple ways you can do this. Now, if x plus 2 is a factor of p of x, then x equals negative 2 is a solution. So if you substitute this into x here pretty much, you should get 0. So that means p of negative 2 must be 0. So if we wrote p of x equals x cubed minus kx squared minus 2x minus 4. If you substitute p of negative 2, the left hand side of this equation should be 0. So you'd have negative 2 cubed minus k times negative 2 all squared, minus 2 times negative 2 minus, oh, that's, I wrote negative 4 by accident, so it's a negative 2 minus 4, okay? So what we have is pretty much, if we simplify this, we have 0 equals, this is going to be negative 8, then we're going to have, that will be negative 4k, because negative 2 squared is positive 4, but you've got a negative k, and this bit here will be positive 4 minus 4. So you can see you've got a linear equation here, but you can see also at the back that these two cancel each other out. So realistically, all you have pretty much is 0 equals negative 8 minus 4k, okay? So bring the 8 to the other side, so it becomes positive 8, so you get negative 4. Then divide by minus 4, divide by minus 4, so k equals negative 2. And that's the solution. You could have also done long division if you wanted to get a remainder of 0. That's the other way you could do it, but this one's a lot more cleaner. Now both ways actually work as well. So I'll show you the other way you could do it as well. So let's just get rid of this. So you can write x plus 2 as a factor of p of x. Therefore we can just say, alright, p of x divided by x plus 2 should give a remainder of 0. Okay, so what we can do is just get rid of this for now and just set up the long division. Okay, this one probably has a bit more probability of getting it wrong, mainly because long division, if you stuff up one negative, then all of it will start stuffing up, but it can be done. So I'll show you how to do it as well. Minus 2x minus 4. Righto, so first of all, same thing with the long division. So you just go this term divided by this term. So that's going to give you x squared up here. And then you get x squared times by x plus 2, which gives you x cubed plus 2x squared. Okay. Then you pretty much go down here. So it'll be subtract x cubed plus 2x squared. Okay. So it's going to be x cubed minus x cubed gives you 0. Then this bit's going to be negative k x squared minus positive 2 x squared. So this is going to be, well, you can leave a negative out the front if you really want to. It'll be a negative, so it'll be negative k plus 2 x squared, and then you bring the rest of this down as well. So you get minus 2x minus 4. Okay. Then we pretty much go do this next bit here pretty much. So what we're going to have is, alright, it'll be this term here divided by x. So I'll just get rid of the room for this. So it'll be negative, oh, got the brackets. So you can see already how a bit complicated this one is going to be, but that's fine. X squared divided by x gives you pretty much, well, you can cancel out one of the x's, gives you that result there. Okay. Then you pretty much take this bit and times it. So negative k plus 2 x times by x plus 2. So the first bit, just treat this term here as a single thing. So it's going to be this times by this and this. So what you're going to get is pretty much negative k plus 2 x squared plus 2 times by, oh well, keep the negative out the front, so it will be negative 2 k plus 2. Okay, so that's that result there, and that's that result there. Then you just write this under here in a freaking negative. So you put it here, big negative out the front. So negative and then negative x squared. Then you have minus 2k plus 2. Okay. Right. So you can see the first term is going to cancel out because it's going to be this whole thing subtract the exact same thing. So you get 0. Now this bit is a bit where it gets a bit weird. So you get negative 2x minus, oh, I forgot the there will be an x here. There's an x here I've forgotten. So there's x there. So it'll be negative 2x subtract negative 2k plus 2x. Okay. So what we can do pretty much is distribute that negative. So you have a positive there, so you can write that as a positive at the front. So it'll be plus. So what we can do here pretty much is you can just think of it like just factor out the pretty much x. So negative 2x plus 2 of k plus 2x. This is the same as negative 2 plus 2 on k plus 2 with a factored out x. Okay, so you can write this guy under here. So if I just move this out of the way. So we can put this here. So this bit will take a bit. So we'll have negative 2 plus 2 on k plus 2 with an x. Okay, you could probably simplify this a bit more at the moment, so we could probably do that. But for now, because remember this bit's going to go here, so we'll have negative 2 plus 2k plus 4 in front of the x. So we'll have 2k plus 2 times by x. So that will be that result there. So we'll have 2k plus 2 times by x and bring that minus 4 down. Okay, and then we're almost done pretty much. Just one more step. You can see this has a bit more complicated steps, but that's completely fine. So now it's going to be pretty much, let's use, oh, that's not the highlighter. So it'll be this guy divided by x. So we get 2k plus 2 x divided by x. So you can see the x cancels out. So you get 2k plus 2 as what goes up there. I haven't been writing them, I've just realized. But that's completely fine. We don't really need to write it. All we want to work out is what k is. So then what you can do then is you can times this guy by here. So you get 2k plus 2 times by x plus 2. So this is going to give you 2k plus 2 times by x plus 4k plus 4. Then you can chuck them down here. So it'll be minus 2k plus 2x plus 4k plus 4. So we have that negative, and we can see those cancel out. So we have minus 4 subtract negative 4k minus 4. And this is going to be equal to 0. Okay, so what we have basically is negative 4 minus 4k minus 4 equals 0. So we have negative 8 minus 4k equals 0. So we get negative 4k equals 8. Divide that by negative 4. And you get k equals negative 2. The exact same answer that we got before pretty much. Okay, it's just a lot more working pretty much. Okay. Let's get rid of this. So let's move this guy, just so it's not in the way of the other bit. Okay, but you can do pretty much either method. One's a bit harder than the other. Like this one here, it's much easier just to sub in x equals negative 1 rather than having that process to deal with, because there's a lot more error you can do in that one there. Okay, but let's take a look at question 4. So question 4, p of x equals x cubed plus ax squared plus bx minus 3. If find a and b if p of 1 is negative 1 and p of 2 is 5. Okay, so what we're going to get is two simultaneous equations for this. Okay, so we can substitute. All right, so x equals 1 into here. So this means when x equals 1, so when p of 1 equals negative 1, when x equals 1, y equals negative 1. So basically, you can go, all right, p of x equals x cubed plus ax squared plus bx. I'm going to write mine as a capital B. Substitute x equals 1, so you get p of 1 gives you 1 cubed plus a on 1 squared plus b times by 1 minus 3. So this left hand side is going to be negative 1, so negative 1 equals, this will be 1 plus a plus b minus 3. So this is equation 1. And then we have p of 2, so p of 2 is 2 cubed plus a on 2 squared plus b times by 2 minus 3. and this left hand side here is going to be 5, and this is going to be 8, this is going to be plus 4a, and this is going to be plus 2b minus 3, okay? And this will be equation 2. So all I care about are those two equations, but this is the first step how you get them. So if we just go here, so equation 1 is negative 1 equals 1 plus a plus b minus 3, so that's equation 1. And equation 2 is 5 equals 8 plus 4a plus 2b minus 3, and this is equation 2, okay? So now you've got those two equations, we can pretty much use either substitution or elimination to pretty much work out what the values of a and b are, okay? So the number of unknowns you have, you're going to need that number of equations. So if you have 4 unknowns, you'll need 4 equations. If you have 10 unknowns, you'll need 10 equations, okay? Now the easiest thing to do is pretty much probably substitution, because equation 1 we can make a or b the subject quite easily. So what we're going to do is just clean up this side. So we'll have negative 1 equals, and 1 plus minus 3 is minus 2, so negative 2 plus a plus b. And I'm going to make a the subject, okay? So subject. So I'm going to move the 2 across, so I'll have negative 1 plus 2, and move the b across, so I'll have minus b equals a, okay? And this is still equation 1. So now what I can do is I can go 1 into 2. So I can substitute this one here in for a, okay? So what I'll have is pretty much 5 equals 8 plus 4 times by this thing here. So that will be positive 1. So it'll be 1 minus b plus 2b minus 3. So you can see exactly where I made that substitution. Now we have an equation just in terms of b, okay? So distribute that 4 to each of the terms here. So we get 5, 8 minus 3 is going to be 5. So we have 5 here plus 4 minus 4b plus 2b. We have 5 on this side and 5 on that side, so they can cancel out. So you get 0 equals 4 minus 2b, because the negative 4b plus the 2b gives you negative 2b. Move the 2b to the other side, so 2b equals 4. Divide both sides by 2, and b equals 2, okay? Then you can then substitute this information back into equation 1. So I'm just going to get rid of this bit here. What have I done here? Yep, positive 1. So plus 1. So if you substitute now this information, that's the same color. I didn't really want that color. Oh well. If you substitute this information into here, you can work out what a is. So you're going to get 1 minus 2 equals a. So therefore a is negative 1, because 1 minus 2 gives you negative 1. So in this question here, a is negative 1 and b is 2. Okay, and that's it. So let's go down to the last question, or not last question, last two questions. So 5 marks, graph this thing here. Okay, so step 1 is we need to pretty much work out all the intercepts. So your y-intercept is when x equals 0. Okay, so if you substitute x equals 0, that term is gone, that term's gone, that term's gone. So when x equals 0, y equals 6. Okay, so we can keep a Cartesian plane in the corner here, so we know the general shape of it. Okay, now we have to look at the cubic itself. Okay, so a standard cubic, so a positive cubic will look like this. So a positive cubic, a negative cubic, so y equals negative x cubed, will look something like this. So the tails will be here if it's negative, and the tails will be here if it's positive, okay? Because our cubic is positive, this is a positive term, my tails are going to be here and here. So I'll leave those on my diagram so I'll know them for later, okay? I also know where my y-intercept is going to be. It's going to be at positive 6, so I know that's going to be roughly about here. So 0, 6, okay? Righto. Now we've got the geometric stuff out of the way, we've got to determine the x-intercept. So the x-intercept is when y equals 0. So what we've got to do is actually the null factor theorem. I like to think of it as just guessing and checking, honestly. So it's just substitute x values. But you don't just choose any x values. You choose ones that are factors of this. So 6 can be composed of pretty much 1, 6, 2, and 3, or negative 2, negative 3, or negative 1 and negative 6, and that's about it. So what you do is you start with this first one, so just negative 1, and I'm going to call my function p of x instead. So what I'll write here is, alright, p of x equals x cubed minus 2x squared minus 5x plus 6. Then I'm going to substitute negative 1 first, so p of negative 1, and I get negative 1 cubed, minus 2 of negative 1 squared, minus 5 of negative 1 plus 6, and then we see if it's equal to 0, okay? So you're going to get negative 1, this is going to be minus 2, because this bit's going to be positive, because negative 1 squared is positive, or any number squared is positive, then it's going to be negative 2. This is going to be positive 5, and this one is going to be positive 6. Now you can see straight away it's not going to be equal to 0, because you have there's two small negatives, okay? Now, then we try positive 1, okay? So rub this out now. And what you do on your paper is you would just substitute, you'd write this again, but all I'm going to do is just change these to positives and see if that changes anything, okay? So this bit's going to be positive 1, this bit will still be negative 2, this will be negative 5 though, and this will be positive 6. So what you get is 1 minus 2, which is negative 1, then minus 7 equals negative 6, plus 6 gives you 0. So this is equal to 0. So we found our first solution, and the only solution we need to find for now, okay? Because then we can use long division to work out the others. So if x, so this is for positive 1, so if x equals 1 is a solution, therefore x minus 1 is a factor. Okay, so now we can use this to work out our quadratic to then break down the other x-intercepts, okay? So start by writing, so x minus 1 divided by x cubed minus 2x squared minus 5x plus 6. Okay, so now we do the long division. Let's get rid of this because I don't need this for now. Righto, so with our long division, we pretty much do the exact same thing we've done in the other question. So this divided by this. So you get x cubed divided by x gives you x squared. Chuck that up there, so x squared. Then you take the x squared and times it by the factor here. So x squared times by x minus 1, which gives you x cubed minus x squared. Chuck that down here, so negative x cubed minus x squared. This gives you, in turn, negative x squared subtract negative x squared, negative 2x squared subtract negative x squared. That's basically going to be negative x squared. The first term we know cancels out to be 0 because x cubed minus x cubed is 0. And then we just move the rest down. So we have minus 5x plus 6. Then it's the exact same process before. So this divided by this. So negative x squared divided by x equals negative x. Then you chuck that up there. So negative x. And then you times it by the factor. So negative x times by x minus 1 gives you negative x squared plus x. Okay, chuck that down here. So negative x squared plus x. So you can see that first term cancels out to give 0. Then you get negative 5x minus x gives you negative 6x, and then plus the 6 down here. Then same thing again. It's going to be this divided by that. So that gives you negative 6. And then I've run out of room. Let's get rid of this. So it will be negative 6 times by x minus 1 gives you negative 6 plus negative 6x plus 6. Move that down there, and you can see this bit here is exactly the same as this bit here. So that gives you a remainder of 0. Okay. So this is the quadratic you get. So this cubic here that we have here, so x cubed minus 2x squared minus 5x plus 6. Is the same as pretty much the following. So x cubed minus 2x squared minus 5x plus 6 equals x minus 1 multiplied by x squared minus x minus 6. Okay, so if this is equal to 0, we can start to factorize the little quadratic here. Okay, so what we do is we ask ourselves is, alright, in this quadratic expression here, what two numbers times to give minus 6 but add to give negative 1? I can think of 2 and 3. So I'll get x minus 3 and x plus 2. So negative 3 times by 2 gives you negative 6, and negative 3 plus 2 gives you negative 1. So that works. So this is the cubic fully factorized. Okay. Now if that's all equal to 0, that means the solutions are x equals positive 1, x equals positive 3, and x equals negative 2. So the opposite signs of the factorized bits here, okay? So now we got the solutions here. Get rid of that. Now we've got to graph our cubic, because remember the question is graph it, so that means include everything, okay? So we have our xy plane here, so x, y, we already know intercept 0, 6, and we know the tails are here and here. Now, positive 1 is here, positive 3 is here, and negative 2 is here. So now it's pretty much threading the needle, okay? So what you got to do is pretty much just go through the dots and follow the tail. So you start down here, so you have to go somewhat like that, okay? And that's your cubic. So this guy here is this one fully graphed. Now to finish it off, you have to label your intercepts, okay? So this was 3, this was 1, and this was negative 2, okay? And that would be it completed. Unless you are asked to find the turning points, but most people won't ask to find the turning points, okay? So let's take a look at question 6, because it's the exact same question, except it's just a little easier. So it's just graphing this cubic here. So what we can do straight away is, alright, y-intercepts x equals 0. So if we chuck an x equals 0 into this here, we can see that's gone, and that's gone. So that means it's 0. So that means our cubic, it's also, we've also got to look at the signs of it. Because it's a negative cubic here, the tails are going to be here and here. But it also goes through the origin. Our cubic goes through the origin. So if it goes through the origin, we know what one of the solutions are, your x-intercepts. So x equals 0 should work when y equals 0. So we write negative x cubed minus x squared plus 6x equals 0. We can see we can actually factorize an x out of everything. So we get x, negative x squared, negative x, positive 6 equals 0. So your first one is x equals 0. And then we also have negative x squared minus x plus 6 equals 0. Then we can factorize this, but before we factorize this, divide everything by negative just to make it a bit easier. So you get positive squared, positive x, and negative 6 equals 0. Now, what two numbers times to give negative 6, but add to give 1? Well, you can think of positive 3 and negative 2. So x plus 3 and x minus 2 equals 0. So that means the solutions for this one would be x equals 0, x equals negative 3, and x equals positive 2. Okay? So we know the tails finish here. Now we got to graph the intercepts. So there's one here, and then there's one here. So just thread the needle pretty much, and you can see it works out. So this would be positive 2, 0. This would be 0, 0. And then this one here would be negative 3, 0. Okay? If you do all this, you'll get full % on this test here, okay? If you have any questions about this test, just leave a message in the comments, or I'll try my best to answer it, okay? But I'll see you in the next one.